Welcome back. I'm Kathy Resnichek.
I'm Richard Pressler.
And we're going to be talking about the first assignment in the Network Fundamentals module. So can you give us a little overview, Richard, about what is going to be addressed in the first assignment?
Yeah, for sure. So we're really going to focus on structured cabling in the first assignment. And basically what this comes down to is data is transmitted in bits. So it's either on or off, essentially. Digital data is transmitted by bits, but there's a variety of mediums they can be transferred over. For example, if you transmit data electrically, then you would need some kind of a wire, copper wire. That's typical. You have some sort of a jack you plug into. Well, all of those are standards as far as the length of the wire before attenuation starts to cause signal loss. You have standards as far as the jack types. You may have heard like RJ45. Those are standards for specific kinds of jacks. You might also transmit the data using light waves. So for example, fiber optic cabling. And in fiber optic cabling, lasers are lighting up the cable, and they're basically being used to communicate with receivers on the other side that are then able to translate those light waves into, again, bits of data. So everything comes down to that fundamental, but there's a lot of choices when it comes to cabling. You can even transmit bits of data wirelessly. That's how your cellular phone works. That's how your wireless laptop works. This course isn't going to focus on that. We're focused on the wired aspect, but there is another course offered through SEDPA K-12, the TAPD organization, that focuses on microwave communication and all forms of wireless communication. But for this course, we're really focused on how data is transmitted over fiber optic and electrical circuits. And one of the things that you're going to learn is that there's limitations, and oftentimes the reason you choose one cable over another is because of those limitations. There's distance limits, there's bandwidth limits, there's other things that are inherent to the cable you choose.
One might work better than another in different situations.
Yeah, as a broad example, when you're connecting two buildings together, you oftentimes are going to go fiber optic. And you'll see why as we go through the assignments. But basically it really comes down to distance, and also the fact that fiber optics are pretty difficult to affect with water.
Oh, well,
it's a strand of glass, you know? So it's pretty impervious when you bury it in the ground. It does a pretty decent job of staying in service for a long time. Whereas copper, if any water gets through the outer sheathing, it could rot or it could, corrode, obviously. And also copper cabling just has distance limitations that are much, much shorter than fiber optic cabling.
But when would you use copper then over fiber optic?
Well, once you're inside of a building, the distances aren't that great. You basically have the distance from the communications closet to the user's desktop. And that distance, as long as it's under about 300 feet or 100 meters, then it's acceptable for modern copper cabling, even up to high speeds. So we've even gone beyond 1 gig. We're now looking at 10 gig copper cabling. And it's acceptable to do that as long as you're within those distance limitations.
So if you were going to describe a typical K-12 network, what kind of cabling systems, or how are those usually laid out in terms of fiber optic versus copper versus other things? Sure.
So as far as what kind first, you typically would go with category 6 copper cabling within the building, and that's going to be used to basically energize. So you're going to have some sort of power over Ethernet, so you're going to send power to power up access points or maybe VoIP handsets, things like that. Copper cabling.
Voice over IP.
Voice over IP, right. And copper cabling is excellent for that because on that copper cable you can transmit data, but you can also send power. And it's very useful for that in a modern K-12 environment. So the access points don't have to have individual outlets, but instead they're powered from the switch, basically.
Oh, that makes a lot of sense.
It's incredibly more efficient.
You don't have to have a plug next to everything.
Or hire an electrician to run an outlet in the ceiling, for this access point. Instead, you just have to have the low voltage cabling going back to the switch. So typically, you're going to see just a lot of Cat6 cabling. Same thing with wired smart boards. It's going to be typically Cat6 cabling. And then from the buildings, you're typically going to see multi-mode fiber until the distances get up over about 1,000 feet, and then you'll start to see single-mode fiber. We do dive into the differences, but in a broad way, multi-mode is a wider wavelength, and single-mode is a narrower wavelength. And the narrower the wavelength in fiber optics, the longer you can transmit it into the kilometers.
Oh,
So with
wow.
single mode wiring, that's the kind of cabling that like a telco would use
Okay.
in order to communicate over long distances, even across the Atlantic Ocean. You know, they have
Yes.
repeaters, but that's typically single mode fiber
Okay.
optics
Very
to get
cool.
that kind of long distance communication.
Great. So that sounds pretty exciting. So the
I
first
hope so.
assignment is all about cabling.
all about cabling.
Yay.